Hi, Assalamualaikum. So today I'm Muaz and then those of my team members, which is Ahmad Arsyad, Imam bin Hamdan, Ameerul Amin Shazza bin Salihuddin, will present about the project material, which is the course number ECS 246. So we are from class J4 EC1104J1, and thank you to and we're gonna present it to our lecturer, which is Sir Johan bin Ibrahim. We will proceed with the introduction, which is we will start with the definition of the sustainable product. So sustainable product can be defined as the product that provided environmental, social and economic benefits while protecting public health and environment over the whole life cycle. So those are several research that we have made in order to determine the future sustainable concrete or bricks, which replacing the fine aggregate for potential application in civil engineering field with the different article. So first of all is replacement of fine aggregate with recycled plastic. So the objective and the question that we have got from this article that this study have been made in order to determine the compression strength of concrete containing a plastic aggregate after the material been added. So secondly, the replacement of fine aggregate with granite shell. So the study have been made in order to determine the density of the concrete and compressive stress of the concrete after the material been added. So this one is also the question and the objective that have been stated in the article. Thirdly, replacement of fine aggregate with burnt and crushed cow bones. So the question and also the objective for this article is this test has been made in order to determine the slump of the material or specimen, and also the compressive strength after the material being added into the specimen. So the last one, the article that we have made is the replacement of fine aggregate with pozzolan. So the objective and the question that we have got from this article, it shows that this test has been made in order to know what is the exactly compressive strength of the specimen after the material been added.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ameer bin Salihuddin, and I'm gonna explain about the suitability of burn and crush cow bones as partial replacement for fine aggregate in concrete. Across the world, cow bones constitute environmental problem in habitats. The foul odor emanating from cluster of cow bones are usually irritating and unwholesome wherever they are dumped. However, their reuse, if perhaps found suitable in a burnt crushed cow bone concrete, could result in the sustainable development of the environment. This research is used for aiming at determining the effect of burnt and crushed cow bones as partial replacement for fine aggregate in concrete. The cow bones that used will be burned for 50 minutes with the temperature is 92 degrees Celsius, and after that the bones will be crushed into a powder. Okay, the objective for this experiment is to determine the effect of water cement ratio on burnt and crushed cow bones. Another one is to determine the effect of burnt and crushed cow bones on compressive strength of concrete. The method that used in this experiment is slump test. The slump test is to measure the consistency of fresh concrete before it sets. It is performed to check the workability of freshly made concrete and therefore to ease with which concrete flows. The slump test is is used to ensure the uniformity for different loads of concrete under field condition. Other method is compressive strength test. Compressive strength test is mechanical test measuring the maximum amount of compressive load for a material can bear before fracturing. The test piece, usually in the form of a cube, a prism, or cylinder, is compressed between the platens of a compression testing machine by a gradually applied load. The advantage for using the burn and crushed carbon as fine aggregate is it can reduce the use of fine aggregate, which means it can cut the cost to buy the material for fine aggregate. Next is to reduce the environmental pollution because the carbon didn't need to throw it away. The disadvantage is the workability. The workability of the concrete will be reduced when the amount of the burnt crushed carbon increase. Next, affecting the concrete will be affected by the cohesiveness of the concrete mix will be affected. The water cement ratio increase when the amount of the burnt crushed carbons increase. Therefore, the slump will be collapsed. Next is compressive strength. The compressive strength for the concrete that were mixed with the 40% and 50% of the burnt and crushed carbon is under the minimum qualification for a concrete in structural work. From this article, there are pros and cons for the experiment, but due to the task, it was a success because it can reduce the environmental pollution. The carbons did not need to be dumped to the garbage dump, but it can be reused. It can be used for construction, and it will also help to reduce the amount of fine aggregate that need for the contractor.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Arsyad bin Rosli, and today I will make a presentation about uses of groundnut shell as fine aggregate replacement. Okay, so methodology for this experiment is the suitability of groundnut shell as constituent material in concrete was invested by replacing proportion by volume of fine aggregate and groundnut shell. Groundnut shell were used to replace fine aggregate at 0, 5, 15, 25, 50 and 75% replacement level. Effect of the groundnut shell on the workability of fresh concrete were determined by the slump and compacting factor value test. Compressive strength and density value of the concrete cube were evaluated at 28 days at different percentage replacement level obtaining. Increase in percentage of groundnut shell in the cube led to corresponding reduction in densities of the cube and compressive strength value. At the replacement value of 25% and above of fine aggregate with groundnut shell, lightweight concrete was produced, which could be used where low stress is required. Hence, groundnut shell can be used for production of lightweight concrete. Okay, this is example for graph sieve size and percentage passing. Okay, so this is the result for this experiment. We can get this graph percentage of groundnut shell and density of concrete cube. Okay, before the compressive strength test was carried out, the weight of the concrete specimen were taken to assess the density of the concrete cube. Figure 3 show the decrease in density of the concrete cube at the replacement of groundnut shell increase, but at 5% replacement there was an increase in the density which might be due to the fact that At that percentage replacement, the weight increased due to absorption of mixing water by the groundnut shell, thereby reducing the water-cement ratio, can making the mixture denser, thus leading to a specimen of high density. Okay, this is the graph for percentage of groundnut shell and compressive strength of cube. Compressive strength from the value obtained for the strength in the concrete specimen, and as shown in figure 4, it can be seen that the strength of concrete decreased with an increase in groundnut shell percentage. It was observed that during soaking, the concrete cube containing more groundnut shell, 50% and 75% replacement, may have absorbed more water, which led to low workability of the concrete mixture, and this contribute to the low compressive strength at this replacement level. Also, the low density of the groundnut shell is compared to that of the fine aggregate it was used to replace, may also have contributed to the low strength of the concrete. Okay, for critique, the replacement of fine aggregate with groundnut shell in the concrete is one of relevant method, as groundnut shell constitute common solid waste, especially in the developing part of this world. Its potential as a useful engineering material has not been investigated. The utilization of groundnut shell will promote waste management, a little cost, reduce pollution by this waste, and increase the economic base of the farmer when such wastes are sold, thereby encouraging more production. Okay, for pros, it will improve concrete affordability, particularly for low-cost housing. Second is production of concrete of a higher quality at lower cost. And lastly, reduce the environmental problem. For the cons, if used too much, it can reduce its compressive stress. Okay, that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Imam bin Hamdan, and I'm from J4 EC 1104 J1 from Civil Engineering Materials. So in this project, we're going to find summarize, critique, and compare the research works in the past 5 years on future sustainable concrete or brick for potential application in civil engineering field. So my findings is about pozzolana cement, which will be mixed in concrete. So in my findings, the introduction is a pozzolana is a siliceous and aluminous material that in itself possess little or no cementitious value, but will, in finely divided form and in the presence of moisture, chemically react with calcium hydroxide at ordinary temperatures to form compounds having cementitious properties. There are two types of pozzolana, which is natural pozzolana and artificial pozzolana. So the objective of the finding is to introduce an eco-friendly sustained material that can be used in concrete for construction. Pozzolana will be used in concrete mixture to help reduce environmental pollutions such as greenhouse effect, etc. It also helps to sustain as material than classical concrete mix, which is an ordinary Portland cement will be mixed in concrete. Assessment of the pozzolanic activity of cement replacement material is increasingly important because of the need for more sustainable cementitious products. So the method that will be used to test this pozzolana material is specific gravity by using a Le Chatelier flask. Soundness is a measurement of its tendency to crack, the soundness of the material. So that this method will be test for expansion after in a certain period of time at elevated temperature in an autoclave machine. So pozzolanic activity index with Portland cement also is one of the tests that will be conducted, and in these findings, and the fineness of these materials will be calculated after wet sieving a sample of pozzolana on a number 3 to 545 micrometer seed. So after the findings, I read the article. So the advantages of pozzolana in fresh concrete is the workability is
The workability is has spherical cement particles in it, and they have higher fineness value. Due to the spherical shape, concrete will move more freely, and more fineness of particles allows for better filling of the pores. This type of cement also gives better cohesiveness to concrete. PPC cement, which is Portland pozzolana cement, also reduce the rate of slump loss of concrete compared to concrete made with ordinary cement, OPC, particularly in hot weather condition. Compressive strength, the strength and rate of strength gain of concrete made with PPC will be equivalent to ordinary concrete at 28 days. The silicate formation of PPC continues even after the rate of hydration of ordinary cement slows down. This results in increased strength gain at later ages. The higher rate of strength gain will continue with time and result in higher later age strength. So that's the advantages of pozzolana. So the disadvantages of pozzolana and concrete is less rate of development of strength initially than ordinary Portland cement. It reduces the resistance to corrosion of steel reinforcement due to alkalinity reduction, but it improves permeability of concrete considerably. And also this pozzolana Portland cement takes longer setting time. For the critics about pozzolana material is based on my findings in many articles on the internet. We can see that there are pros and cons on using pozzolana material in concrete, but the most important thing is that the pozzolana really helps in reducing the environmental pollution, which is the main objective of this assessment. Because as an engineer in the future, we need to use materials that very sustainable, with high sustainability to help reducing the environmental pollution in Earth. The production and process of making the pozzolana and the findings of the pozzolana material that release less carbon dioxide compared to ordinary Portland cement, which is using and in the process release many carbon dioxide, so that it really harm the environment, which lead to environmental pollution. That's all for my critics. Thank you.
Okay, so next we will continue with methodology. So for the methodology that this replacement of the fine aggregate with recycled plastic in the concrete, which is we will do a precast concrete. So this precast concrete, the procedure is, first of all we have to prepare the yeast mixture, consists of 695 kilogram meter square sands and 1133 kilogram meter square meter cube, and then cost aggregate 465 kilogram meter cube cement, a water content ratio which is 0.4, and 0% of plastic waste for the first test. So the specific gravity test being used to get the plastic granule, which is 0.7826 specific gravity. So this all is that the test that we use that has been provided from the article. So after that we will feed all the material into the mixer, and then we will mix within the time 1.5 to 2 minutes, and then after the all gradients are all added, so start the mixer after the time needed have reached and put it in the cube mold with the dimension 150 times 150 times 150 millimeter. So compare each layer of the mold to make sure there is no voids. After the top layer has been compact finished, the surface of the concrete in level with the top of the mold by means of the trowel. Cover the molds with them. So after that we will submerge our cube into the water. So this is the first precast concrete. This is the first precast concrete of this compression strength test. So after that we will move into the compressive strength of the concrete. So this cube that immersed in the water will be taken out after being kept for curing period of 7 and 28 days before testing. So the surface will be dry with cloth before being taken to the compression machine. It is because of we want to avoid any electrical shocks from the water into with the electric like we switch on the main switch, or like the water will drop it into the machine, so it will harms the machine. So the dimension of the specimen will be determined and record the data. So as we mentioned, we use the cube 150 times 150 times 150 of millimeter. So it shows that our sample will get is 150 times 150 times 150 millimeter of the cube. So after that, the specimen being weighed and record the data. So after that, the cube will be placed in the testing machine and place it centrally to make sure the load should be applied to the opposite sides of the cubes. So the load will be applied to the cubes without shock and increase continuously until no greater load can be sustained. So the compressive strength of the specimen will be recorded together at the maximum load and appearance of failure. So this step will be repeated by adding the 5%, 10%, 50% and 20% of plastics, recycled plastic into the mix of proportional. So next, for this methodology, what can we get from this this replacement of aggregate with recycled plastic in concrete? What we get is difference for this article or methodology we get is reduce harmful to environment, as we know that plastic will harms a lot of environment, as it's to make its dispose, it's taking a lot of time. So next is increased compressive strength of concrete. It can be proved by the result in the findings. So next is lower carbon emission. So as we all know, concrete will using a lot of carbon dioxide. So the included of this plastic, recyclable plastic, so it will reduce the carbon dioxide emission. So for the cons of this replacement of aggregate with recycled plastic in the concrete is it increased the cost to dispose the plastic waste. This plastic, we just cannot take the originally plastic, so we must make sure that the plastic is already disposed and recycle it and being effective to the gamma to make sure that the plastic can be placed into the concrete replaced with the fine aggregate. So the next cons of this article is it shows that it's having a low bonding properties, which is will makes the concrete having a low tensile strength. So after that, the melting point is low, as because of as we all know, plastic having a low melting point. So the included of plastic into the concrete, it can be said that is cannot suitable to be used in the furnace. So that's all for the pros and cons of replacement of fine aggregate in the concrete. So next we will continue with the findings. So for the result that have been shown in the slide, so it shows that the result of the 7 days, the percentage of plastic which is natural concrete is have compressive strength 24.44 Newton millimeter squared. So for the 10%, 15%, 20% and 25%, it shows that every percentage increase, the more the compressive strength will be reduced. Such as you can see, 10% will having a 22.22 Newton meter squared. 15% of percentage of plastic we having 21.11 Newton meter squared. 20% is 19.55. 25% of percentage of plastic having compressive strength 17.55. So it can be shows that for at 7 days of the concrete test, the natural concrete having the higher compressive strength rather than with the plastic. So at the 7 days, the compressive strength of the natural concrete is slightly better than the plastic replacement of plastic with replacement of fine aggregate with the plastic. So, but we can see with the last test, which is 28 days. So from the result after the 28 days, the percentage of plastic in the natural concrete, it has the compressive strength 26.8 Newton millimeter square. So next, after we added with the 5% of the percentage of plastic, its compressive strength is increasing. So it's having a 29%, 29 Newton per millimeter square, and then 10% 30 Newton millimeter square, and the 50% 28.5 millimeter square, and 20% of percentage of plastic having a compressive strength 27 Newton millimeter square. So it can be shown that the plastics, the more lower of the plastics, which is not the more lower, is such as around 5 into 10%, it will produce a higher compressive strength of the concrete if we put the percentage of plastic around 5 into 10%. So it can be shows that plastic having it can be shows that the pros of the replacement of fine aggregate with the concrete, it shows that the plastic really give the concrete the higher compressive strength rather than the natural concrete. So for the what can I conclude from this finding? At the 7 days of the test, it shows that natural concrete having the more higher compressive strength, and the lower is at the 25% added of percentage of plastic, which is having the compressive strength 17.55 Newton per millimeter square. So at the 28 days, it shows that the higher percentage of the compressive strength is when we added 10% of percentage of plastic into the concrete. As because of we get the higher compressive strength 30 Newton per millimeter square rather than the lowest one, which is the natural concrete, which did not added with any any plastic. So the lowest is 26.8 Newton per millimeter square with no percentage of plastics. So that's all for me for the findings of this article, replacement of fine aggregate with plastic, recyclable plastic in the concrete.
For discussion, all the material that has been chosen to replace as fine aggregate is very good to prevent from environmental pollution, which is pozzolana, cow bones, groundnut shell, and plastic. All of them will prevent the environmental from pollution. But the most effective material that can be used for concrete is plastic. This method shows that the objective of the test is achieved as the fine aggregate can be replaced with recycled plastic to get higher compressive strength. Replacement of fine aggregate with recycled plastic in the concrete is one of relevant method, as nowadays plastic were the one of important things in daily life. So there will be no limitation to get recycled plastic, but there will be limitation when adding recycled plastic into the concrete. Furthermore, from the finding, it shows that replacement of fine aggregate with plastic will increase the compression strength of the concrete. For example, 10% of plastic will give 30 Newton over millimeter square compared with natural concrete, which 26.8 Newton over millimeter square. The result is accurate as the same tests have been repeated by others in other articles, and it shows the same result. The result, which convincing, is 10% adding to the mix proportion as it's having the higher compression test compared with else. Lastly, this replacement of fine aggregate with the recycled plastic can be replaced in future as it gives more advantage rather than traditional one that's still being used nowadays. The major thing is it's really help environment with producing less carbon dioxide emission rather than the natural concrete.